set to our carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
The most distant human-made object, NASA's Voyager 1 spacecraft, is in interstellar space.
Space, with its vastness and mysteries, has always captivated human curiosity. And as our technology advanced, we launched probes and satellites into the great unknown, hoping to unravel the secrets of the universe. Among these explorers is Voyager 1, a spacecraft that has journeyed beyond our solar system, sending back valuable information about what lies beyond. However, Voyager 1's recent message isn't mere data. It's an alarming warning that might revolutionize our cosmic comprehension. What could have prompted this iconic vessel to break its long silence with such a terrifying message? Could it be a dire warning from the far reaches of space, a sign of cosmic calamity hurtling toward our planet? Join us as we navigate the depths of space and decode the terrifying message echoing from Voyager 1. Voyager's leap into interstellar realms. For nearly 45 years, the Voyager missions have been major players in space exploration. They've been instrumental in uncovering some of the earliest and most mind-blowing discoveries about our solar system. Here's the fascinating part. These missions weren't initially intended for the long haul. It was more of a fortunate turn of events than a deliberate plan. In the 1970s, Mikhail Minovich had a stroke of genius. He conceived the idea of using a planet's momentum to propel a spacecraft even deeper into space, like a slingshot. This accidental discovery laid the groundwork for what eventually became the Voyager missions. When NASA initiated the Voyager mission, they initially expected it to last around 5 years. However, Voyager 1 and Voyager 2 have defied expectations, persisting far beyond their initial projections. These spacecraft continue to traverse space, gathering remarkable scientific data from the outer reaches of our cosmic vicinity. In the past year, scientists unveiled a staggering revelation about Voyager 1. It recorded a humming sound associated with waves found in small quantities of gas dispersed across the expansive void of interstellar space. However, before we delve into this particular detail, let's take a closer look at the extraordinary journey of the Voyager mission. You see, in the summer of 1977, NASA launched two remarkable spacecraft, Voyager 1 and Voyager 2. These twins were on a mission to explore the mysteries of our solar system. Starting with Jupiter and Saturn, the spacecraft excelled in studying the planets, delivering exceptional results that provided groundbreaking insights. However, their journey continued. Voyager 2, driven by its determination, accomplished a historic feat. It provided humanity's first close-up view of Uranus in 1986, followed by a remarkable encounter with Neptune in 1989. These orbits of the four planets earned the mission the name Voyager Grand Tour, a well-deserved recognition of their achievement. After their celestial sightseeing, the Voyagers weren't ready to hang up their hats just yet. They embarked on a new quest, one that took them beyond the confines of our solar system. In 2013, NASA made an incredible announcement. Voyager 1 had crossed the boundary that separates our solar system from interstellar space. Picture this as the threshold between where the sun's influence ends and the space between stars begins. This interstellar space, as scientists call it, marks the point where the flow of particles and magnetic fields from the sun fades away. Voyager 2, not one to be left out, followed suit in 2018, joining its twin in the vastness of interstellar space. At that moment, it was a staggering 17.7 billion kilometers away from the radiant warmth of our sun. But hold it, there's more. The Voyager spacecraft stands as the pioneer in interstellar exploration. Their journey into this uncharted territory has unraveled a wealth of knowledge about the interactions between our solar system and the vast expanse of interstellar space. One of their key investigations revolved around how the interstellar medium, basically the elements between stars, interacts with the solar wind. the constant stream of charged particles emitted by the sun. This interaction zone, where these forces collide, holds crucial information. The Voyagers have been instrumental in shedding light on the heliosphere, a protective bubble formed by the solar wind that envelops our solar system. Picture the heliosphere as our cosmic shield, shaped and influenced by the conditions in interstellar space. The precise boundary where the solar wind ends and interstellar space begins is called the heliopause, and it's a hotspot of scientific curiosity. This is the point where the Voyagers crossed into uncharted territory, providing NASA with a goldmine of information about what lies beyond. Thanks to the Voyagers, we've learned fascinating things. For instance, beyond the heliopause, cosmic rays are about 3 times more intense than within the heliosphere. This discovery sheds light on the environment outside our solar bubble. Scientists have eagerly combined the Voyager findings with data from subsequent missions, creating a more comprehensive understanding of our sun and how the heliosphere interacts with the dynamic realm of interstellar space. This collaborative effort has been essential in expanding our knowledge of the solar system's boundaries and the cosmic neighborhood beyond. Now let's explore the unsettling message sent by Voyager 1 from outer space. Voyager 1 sent out a terrifying message from space. Last year, scientists made a mind-blowing announcement about Voyager 1, revealing that it captured a humming noise linked to waves detected in tiny amounts of gas floating in the vast emptiness of interstellar space. Nicola Fox, NASA's Heliophysics Division Director in Washington, D.C., emphasized the significance of Voyager's missions. She highlighted how these missions, spanning 45 years, have been invaluable in unraveling the mysteries of the sun and its influence throughout our solar system. These Voyagers are no ordinary spacecraft. They're powered by a plutonium-based thermoelectric system. As this plutonium ages, the heat it produces decreases, causing these probes to lose power over time. To cope with this power decline, NASA's team made strategic decisions, turning off non-essential and even some initially deemed necessary systems. This included shutting down heaters meant to protect vital instruments from the harsh cold of space. Here's the fascinating part. All 5 instruments had their heaters turned off since 2019, and they're still up and running, operational, despite the freezing temperatures. NASA's experts are scratching their heads, puzzled by how these Voyagers are defying their design limits, continuing to operate in conditions way colder than they were originally built for. It's a cosmic mystery that keeps the scientific community intrigued. Something pretty peculiar's been brewing at the edges of our solar system, specifically at the heliopause, that boundary dividing the heliosphere from the interstellar medium. Scientists have noticed some unexpected ripples and strange angles cropping up there. This isn't the first time we've known that the heliopause shape can alter. Over the past decade, researchers have realized it's not a fixed structure. Our insights into this come from data gathered by only 2 spacecraft that have breached the heliosphere, Voyager 1 and Voyager 2. Alongside these intrepid probes, NASA's Interstellar Boundary Explorer, IBEX satellite has been peering into the emissions of energetic neutral atoms, ENAs. These ENAs are produced when the solar winds and the interstellar medium collide. The Voyagers offer direct, on-the-spot measurements of these boundaries, but it's just a snapshot at one point in both space and time. Jeremy Bernstein, a space physicist at Princeton University, highlighted this limitation, mentioning that IBEX fills in some of those gaps, adding more depth to our understanding. Thanks to this collected data, scientists have cooked up models to predict how the heliopause might morph in the future. It's a dynamic dance out there, with solar winds and the interstellar medium tugging and pushing at each other, constantly shaping and reshaping this boundary. It's like a cosmic tug-of-war playing out at the very edge of our cosmic neighborhood. But that's not all. Heliopause's unpredictable dynamics. New findings about the heliopause are causing quite a stir in the scientific community. Scientists have found new info that doesn't quite match what they thought they knew before. Back in 2014, a spacecraft named IBEX observed an unusual occurrence, a sudden increase in the brightness of energetic neutral atoms, referred to as ENAs. This indicated a potential imbalance at the heliopause. But later, when scientists looked deeper, they saw that these lopsided patterns didn't fit the models they had. Then, using data from Voyager 1 and Voyager 2, they realized that the heliopause was on the move, and fast. This movement explained why these two probes entered interstellar space at such different times, even though they started their journeys years apart. This discovery flipped some theories on their heads. Scientists called these differences entry speaking, which means they were unexpected and kind of controversial. They published their findings in a science journal called Nature Astronomy on October 10th. But guess what? They're not done yet. Scientists want to keep digging into this mysterious heliopause, and they're eagerly waiting for a fancy new satellite called NASA's Interstellar Mapping and Acceleration Probe, set to launch in 2025. This satellite is like an upgrade, able to spot those enigmatic, energetic atoms. So until then, we're left speculating about these strange happenings in the depths of our solar system. It's like a ghostly mystery waiting to be solved. AACS anomaly unveiled. In May, Voyager 1 encountered an anomaly with its attitude articulation and control system, AACS, responsible for orienting its high-gain antenna toward Earth. Instead of its regular health and status reports, puzzling data was transmitted. This situation mirrored a kind of electronic aphasia, akin to a disruption in fluent communication. The data appeared scrambled, resembling random gibberish, prompting NASA to suggest that these signals might not accurately depict the spacecraft's condition. It was likely a chaotic jumble devoid of genuine meaning or purpose, indicating a potential issue or glitch within the AACS system. What made this whole situation even more puzzling for the engineers was that, despite these weird updates from Voyager 1, the spacecraft itself seemed just fine. Its radio signal remained strong and steady, indicating that the antenna was still locked onto Earth, contradicting what the AACS was claiming to NASA. Plus, Voyager 1's science systems kept doing their job, collecting and sending data like they always had, even while the AACS was acting strangely. What's wild is that whatever was going on with the AACS didn't trigger any safety measures designed to protect the spacecraft. Usually, when there's a hiccup, a fault protection system kicks in to keep everything safe, but not this time. Thankfully, NASA's sharp engineers cracked the puzzle. They found out that the AACS had been using a computer that had stopped working years ago to send its updates. They simply needed to instruct the AACS to utilize the correct computer for transmitting data. The malfunctioning of the old computer caused disruptions in the information being sent out. Once they made the AACS switch computers, the problem was fixed. However, there is a big challenge: Voyager 1's battle with cosmic wear. Figuring out why the AACS decided to switch systems in the first place is a big challenge. According to NASA's findings, it appears that the system received an incorrect command from another computer on board, causing a disruption. They say it's not a big worry for Voyager 1's health right now, but they want to find the root cause to avoid more strange surprises in the future. Voyager 1 has been out there cruising in interstellar space for the past decade, far away from our sun's protective magnetic field. See, that magnetic field shielded the spacecraft from cosmic rays and other space radiation, kind of like how Earth's magnetic field protects us from the sun's radiation. But out in interstellar space, Voyager 1 doesn't have that shield anymore. When swift particles zoom past and strike the computer chips on board, they can create small memory glitches that accumulate gradually. It's akin to the wear and tear caused by various elements floating around in space, and Voyager 1's onboard computers might be feeling the effects. Susan Dodd, the project manager for Voyager 1 and 2, mentioned that these kinds of mysteries are part of the deal at this stage of the Voyager mission. After all, both spacecraft are around 45 years old now, way longer than what they were originally built for. Plus, they're in a space environment filled with high radiation that no other spacecraft has ever experienced. The journeys these spacecraft have taken so far have been truly remarkable. Thanks to its continuous upgrades, Voyager has surprised us by exceeding its projected limit. However, another thing that has proven to stand the test of time with super cool upgrades is our brand new JWST Special Edition phone cases, which are currently on sale for the new year. Discover them right now by clicking on your screen or checking the first link in the description. How confident are you in scientists' interpretation of Voyager 1's heliopause data? Share your thoughts in the comments below.